Good morning. Welcome in lecture number 2. I hope you all are safe and healthy at your home. In this COVID-19 pandemic situation, please follow government's rule and regulation for our best society. In lecture number 1, we see synthesis of chloroquine as a anti-malarial drugs. Now, in this lecture, we see one is Primaqueen and second is chemoqueen. So, first of all, we see Primaqueen, synthesis of Primaqueen. Primaqueen is synthesized by 2,4-bromopentyl isoindole 1,3-dione. This is the intermediate step of Primaqueen. So, first of all, we synthesize 2,4-bromopentyl isoindole 1,3-dione. Synthesis we have started by these two type of our raw material. It is described in one is potassium thalamide and second is 1,4-dibromopentane. 1,4-dibromopentane. Condensation of both compound potassium thalamide and 1,4-dibromopentane gives the 2,4-bromopentyl isoindole 1,3-dione. We give its name as compound 1. In this reaction, we see detail our starting material potassium thalamide, here from potassium, and 1,4-dibromopentane, here from bromine, Br. Both potassium and bromine are removed, so minus Kbr, and condensation process gives 2,4-bromopentyl isoindole 1,3-dione as our compound 1. Now, for synthesis, we start from 2-nitro-4-methoxyaniline. 2-nitro, we give the numbering as a 1, 1, 2, 3 and 4. So, its name was 2-nitro-4-methoxyaniline. This 2-nitro-4-methoxyaniline is treated with propane 1,3-triol, propane 1,3-triol, and in presence of sulfuric acid. This synthesis is known as SCRAM synthesis. SCRAM synthesis, and we get 6-methoxy-8-nitroquinoline. 6-methoxy-8-nitroquinoline, and for this compound we starting numbering from nitrogen as a 1, 2, 3, 4, 5, 6, 7 and 8. So it is 6-methoxy 8-nitroquinoline. Now we started reduction of this 6-methoxy 8-nitroquinoline with some reducing agents. Therefore, we state in reaction this nitro group NO2 is converted into NH2 by reduction unit process. So we get 6-methoxy, numbering we state above, 6-methoxyquinoline 8-amyl. This compound 6-methoxyquinoline 8-amyl is condensate with our compound number 1, which we synthesize above, and condensation of our compound 1 and this quinoline derivative gives the 2,4,6-methoxyquinoline 8-amino pentyl isoindole 1,3-dione. Please write the structure and its name. This compound is 2,4,6-methoxyquinoline 8-amino pentyl isoindole 1,3-dione. Now, at last, we treated this compound 2,4,6-methoxyquinoline 8-amino pentyl isoindole 1,3-dione with NH2 NH2 hydrazine, NH2 NH2. In presence of hydrazine, the reaction takes place and one NH2 is here bonded and phthalimide compound remove, and finally we get our component Primaqueen. Next, uses of Primaqueen. It is the best and most effective antimalarial of this class, that is 8-aminoquinolines. In first lecture, we state that quinoline is natural component and synthetic derivatives of all quinolines, synthetic components are antimalarial activity. So it is 8-aminoquinoline derivative. It has been found to be about 1/2 as toxic as Primaqueen. It is the next component of this group, Primaqueen, but 4 to 6 times more active as ixorerocytic schizontoside in the case of Plasmodium vivax infection. Even complete cure can be effected in most Plasmodium vivax infection. This is the synthesis and its usefulness is described here. Now, today's second component is chemoqueen. In the synthesis of chemoqueen, we synthesize it in two parts. First of all, we synthesize 4,7-dichloroquinoline, and second component 4-amino-2-diethyl-aminomethylphenol, and then both are condensate gives chemoqueen as a anti-malarial drugs. So first of all we synthesize 4,7-dichloroquinoline. In lecture 1 for chloroquine, we synthesize 4,7-dichloroquinoline. We give in that synthesis compound 2. But in synthesis of chemoqueen, we give our name as a compound 1. So first of all, we synthesize 4,7-dichloroquinoline. First of all, we start from ethyl acetate and diethyl oxalate. Both components are reacted in presence of methanol and sodium ethoxide gives 2 sodium this compound 2 sodium oxide succinic acid diethyl ester. Now, 2-sodium oxide succinic acid diethyl ester is treated with acetic acid CH3COOH. On reaction gives 2-hydroxy succinic acid ethyl ester. So both are ester derivatives. Both are ester derivatives. Now these derivatives are rearranged. First of all, we see the 2-hydroxy succinic acid diethyl ester, and second is 2-oxosuccinic acid diethyl ester. In this structure, here hydrogen H is transferred to its above position. Therefore, the change is CH2 and in below here COH is converted into CO. So it is 2-oxosuccinic acid diethyl ester. Now it is treated with metachloroaniline. Cyclization process takes place. Water molecules H2O are removed and we get 2,3 chlorophenylaminosuccinic acid diethyl ester. It is also a ester derivative. Now it is treated with ethanol at temperature of 250 degrees Celsius. Here it is noted that if the temperature is not exactly 250 degrees Celsius, then the reaction is not take place. So be careful for the production of chemoqueen in presence of ethanol with 250 degrees Celsius gives 7-chloro-4-oxo 3,4-dihydroquinoline 2-carboxylic acid ethyl ester. It is also ester derivative. Now it is rearranged. It is rearranged. Rearrangement shows that here is double bond with oxygen. It is converted and this carbon contains hydrogen. So this hydrogen is transferred to oxygen and OH and double bond is transferred here. Now we get by rearrangement 7-chloro-4-hydroxy, this compound. First name was this, and second 7-chloro-4-hydroxyquinoline, 2-carboxylic acid ethyl ester. Now, hydrolysis of our compound 7-chloro-4-hydroxyquinoline, 2-carboxylic ethyl ester gives 7-chloroquinoline for all. 7-chloroquinoline for all. And this compound is treated with POCl3, phosphorus oxytrichloride. Phosphorus oxytrichloride. Therefore, conversion of OH group into chlorine. So we have finally product 4,7-dichloroquinoline, and for this synthesis we give its name is compound 1. Its name is compound 1. So this is 4,7-dichloroquinoline. Now for second compound 4-amino-2-diethyl-aminomethylphenol, we synthesize it from para-acetyl-aminophenol. Para-acetyl-aminophenol. Here describe it. Para-acetyl-aminophenol. It is treated with diethylamine N2C2H5 twice diethylamine in presence of HCHO methanol gives the product namely N3-diethylaminomethyl 4-hydroxyphenyl acetamide, and on hydrolysis it gives amino, the compound number 2. We give name it as a compound number 2, 4-amino-diethyl-aminomethylphenol. So this is our compound number 2. Now compound 1, 4,7-dichloroquinoline, and compound 2, 4-amino. In this reaction there is some mistake here, that is here as a NH2. So it is 4-amino-2-diethylamino-methylphenol as compound number 2. Now condensation of compound 1 and compound 2 gives the, here from this NH2 and Cl, so minus HCl, so HCl remove and condensation take place and we get our product chemoqueen. It is anti-malarial drugs. By this route, we synthesize chemoqueen as a anti-malarial drugs. Now, uses of chemoqueen. It has been found to be 3 to 4 times more active than quinine. Quinine is natural component, so it is 3 to 4 times more active, especially against the malaria caused by vivax and falciparum species of Plasmodium, especially for Plasmodium vivax and Plasmodium falciparum. It is important to observe that the phenolic group is essential for its antimalarial activity. If phenolic group is not present, then it is not active. Since its removal depresses while its methylation completely destroys the antimalarial activity. Thank you.